Hey you guys, what's up? This is Prachurja and you are listening to my lectures on kinematics and laws of motion, my physics tutorials. Let us continue with what we end up with in last lecture, and that was the laws of motion. So first of all, let's start with Newton's first law. Today we want to discuss what are the laws of motion. And first of all, which is the most important of all and most basic of all, is the Newton's first law. And the Newton's first law states that an object will maintain its current state of rest or uniform velocity unless acted upon by an unbalanced force. Now let us understand each and every word of this statement here. An object will maintain its current state, like the state in which it is currently present. That is the current state of that body or that object of rest. It can be either in two ways. Either it can move or it can be at rest, that is zero velocity. Current state of rest or uniform velocity. It's also mentioned uniform velocity. This sometimes may be applicable to accelerated motion, but most probably it is applicable to uniform velocity things only, unless acted upon by an unbalanced force. Now that is very important. Unbalanced force. Now let us look the history behind this first law, then we can understand it really neatly. Now this is the person here who did all this stuff out right here. He started the first law of motion, and he saw, using this experiment here which we have here, this experiment, he saw that when a ball was kept on two inclines kept at a certain distance, and he tried to make that incline and the distance quite frictionless, he saw that the ball, if when released from a height h, moved in this direction and came up to same height h approximately. Since he could not neglect the whole friction, this came into picture. Now friction is a force that is applicable on it. So in case we take friction absent, then there is no force except the force, the weight. Now if there is the force of the weight, then there is a normal reaction too. That is the force that is coming from the incline itself. So they both are balanced forces, not unbalanced forces. So we can see that the body is coming down and then moving up to the same height as it was released, and then in the next step it would come symmetrically to its initial position. That is the Newton's first law or Galileo's inertial law. That's where inertia comes from. Now let us consider these two photographs that we have, these ones, right? Now we have two footballs. One football is lying on the ground without any motion. There is nobody kicking on it. No player is playing on the field, and the football is kept like that. So we can say that by common sense we can say that this is not moving. There is no one hitting the ball. That means there is no force that is pushing the ball for motions. So we can say that the first statement, that what an object will maintain its current state of rest or uniform velocity, the object will maintain current state of rest unless acted upon by an unbalanced force, is true. Now you will say that there are forces applicable on it. We say that the force of gravitation is applicable on it. But in case the force of gravitation applicable, there is a similar normal reaction coming from the earth. The normal reaction is the interaction between the molecules of the surface of the ball and the earth, which tend to be repulsive and attractive as per distance occurs, and this force normally tends to balance the weight of the body in planar surfaces. Now we'll talk about normal reaction, other forces later. Let's just discuss about how the forces are balanced here. Let us suppose that this ball has a mass of around 20 kilogram. So we say that the weight is equal to m into g. Now here m here is 20 kilogram, right? And g is always a constant of 10 meter per second square. So this weight is not the it's this weight is not the mass of the object. It gives us the force that the earth pulls it towards. Right, it is the force in which the earth pulls the ball towards it. Now let us suppose we have here, we take a weighing machine. There's a weighing machine right here, and we have kept the ball on it. Now what does the weighing machine weigh? The weighing machine weighs the weight of the body, divides it with the value of g, and thus give us the mass. But actually it weighs the normal reaction of it. We will learn it in the third law, that every force has an equal and opposite force acting on the complementary particle. But here if we see in a small view, that when the ball is kept on it, it is forcing the above plate to come down so that the reading could change. So that is the normal reaction that is happening, which is equal to the weight of the body. Therefore we can say that there is a balanced force on the body, and thus it is not moving. Now let us take this football. Now as you can see that it is being hit in any of the four lines here. It can be hit on the four lines here. Now at this point let me draw the weight here. Right, let me draw the weight, and then I said that there is a normal reaction coming from the ground. So now let us suppose that it is being hit at this position by Cristiano Ronaldo. Right, now he hit it very hard at this position. Right, so now there is an unbalanced force on this ball, and this will fly in the direction the force is coming, which is given by the second law of motion. Thus the second statement, that the object will maintain its uniform velocity unless acted upon by an unbalanced force, is called the unbalanced force is the first law of motion. Thus the total first law of motion includes the current state of rest as well as the uniform velocity motion. Now let us take another example before moving to the second law. Let's now consider what was happening in this example of Galileo's experiment. Let us draw it again. We have an incline here, and I tend to make it a bit. So here we have two inclined planes and a small ground, and we are assuming that the friction here is 0, where mu equals 0 is the coefficient of friction, which we will discuss later. Just let me tell you that mu tells us that how much the friction is. The higher the value of mu, the more the friction. If the value of mu is equal to 0, then there is no friction. Just remember that. Now this is what is happening. Now let us consider this ball. Always another thing to note is the normal reaction is always perpendicular to the surface on which the object is resting or moving. So let us draw our ball here. We have the ball here, and it is moving down. Right, it's moving down like this. Now we know that the weight is directed down towards the earth. So this is the weight that we are talking about, and there is another force which we are calling the normal reaction, and it is perpendicular to this surface here. Right, and this is the normal reaction. Now you would say, if you have learned vector analysis, that force are vectors and they cannot cancel each other. I am also not saying that they will cancel each other. Now what we have to do is break the weight of the body into two components, because now it is a vector quantity, so we can break it into two components, but this time we will tilt the xy plane. Now how will we tilt the xy plane? Let us suppose that the xy plane is something like this. It is the x direction is along the incline and down the incline, and the y direction being perpendicular to the incline. So we now will have two components of this. Okay, now this is the one component which is along the x-axis and another component out here. So you will see that the balance forces will be these two. These two will cancel out each other and thus they are balanced. But this component is still alive. Thus this component will accelerate the body. It will tend to move the body. Thus there is an unbalanced force and thus it is moving. Now we see that there is no friction acting on it. Now the body is now coming down. Right, let us suppose the body is now here. Right, the body has reached this position. The body has reached this position and it is moving in direction. Now let us draw the vectors. Now one is a normal reaction vector, which is the normal reaction, and another one is the weight vector. Now this time we can say that the weight and the normal reaction cancel each other and thus it has a balanced force. These are acted upon by balanced forces. Right? So these are now acted upon by balanced forces. Thus now if it is moving with a velocity of v, which we can calculate in our later lectures, it is moving with a velocity of v, it will continue to move with a velocity of v. And thus now at this position, when it comes at this position, it still has its weight acting and the normal reaction acting. So still the normal reaction is equal to the weight, so still it is unbalanced form. But once it reaches at this position, the same thing happens. The normal reaction becomes perpendicular to this and the weight we were talking about is now like this. So there is an unbalanced force which will deaccelerate the ball and thus it will come to rest at the same position, because the position, we can say that the situation is quite symmetrical. It is moving with a velocity of v at this position, so it has to come to at that position, which we can prove in a later lecture. So that was all about first law of motion, which denotes the property of inertia. We'll discuss the small topic of inertia in the next lecture, but please kindly revise about inertia before you attend this lecture. Thank you so much.